Today's LeetCode problem is longest common suffix queries. This is question 4 in weekly contest 390. Usually question 4s are the hardest questions of the week, but this one is surprisingly simple if you know which data structure to use. So in this video, you will learn a powerful new data structure and how to solve this hard but not too difficult LeetCode problem. Let's get to it. You are given two string arrays, words container and words query. For each query, you have to find the string in words container that shares the longest common suffix with that query. Well, that's it. Although there are a few gotchas, so if two or more strings have the common suffixes of the same length, then you need to choose the shorter string. And if two or more such strings of equal length, then choose the one that occurs earlier, i.e. has a smaller index. Return an array answer, where answer I is the string with the longest common suffix for query I. Let's look at an example. The first query is GH, all three words end with GH, so we pick the shortest word, which is at index 2. I'm not going to try and pronounce it. Thus, the first entry into answer is 2. The second query is ACBFGH. Now, this looks deceptively like the first word, but you look closely, their actual common suffix is only FGH, which is of length 3. The other two words share only GH though, which is even shorter. So this time we pick the first word who has the longest common suffix with ACBFGH, and thus the second entry into answer is 0. The third query looks again a lot like the first word, but this time their longest common suffix is only GH. Too bad, looking similar is not good enough. The second and third words also have GH as their longest common suffix, so again, just like in the first query, we pick the shortest word, which is at index 2. Now, whenever you want to look up strings by their prefixes or suffixes, you should immediately think of a trie. A trie is a multi-way tree structure where each node has up to 26 children, one for each letter of the alphabet. To insert a new word, you iterate through the letters of the word one at a time, traversing down the child for that letter each time. Let's start by adding the word AND. From the root node, we add children for A, N, and D. The word N then goes into the D node. Now, when we add the word any, the trie already has A and N, so now all we add is a new node for Y. Again, the word any goes into the Y node. We keep going for the rest of the words here. Bat, B-A-T, bow, B-O-W, ban, B-A-N. Our last word is Andy, and now we see why we need to add the word to its final node. Not every word terminates in a leaf node, so if we don't add words into node where they end would simply get lost in Andy. We can modify the trie to answer different questions. If we had wanted to know how many words start with a certain prefix, we would add a counter to the nodes for each word that passes through it during insertion. In our question, we want to know which words start with a certain prefix. So we just keep a list of words instead of a counter. In theory, we can always write a simple DFS to collect words from all of the node's descendants instead of using this tracking list, but the list does make life a little easier. Looking at the result is very similar to insertion. You step through each of the letters one by one until you reach the end of the word. If you're still watching and you're enjoying this video, make sure to check out the rest of my channel. We have LeetCode problem solutions, weekly contest live streams, and general tips about technical interviews. Like and subscribe to stay up to date every time a new video drops. For contest purposes, I have a try class written beforehand and I keep it in GitHub. It can then be modified whenever I need one. You can use someone else's template or mine. The GitHub link is found in the video description, but I find it fastest to modify if I wrote the code myself. It is also good programming practice for you to write your own try class from scratch. The basic trie node uses a dictionary or hash map to store its children. For this question, we will add items, which for now is just an index of words from words counter. The idea is, as we insert a word to the trie, we add the index of the word to every node it passes through. Storing the index saves us space compared to storing the full actual words. The insert function at the root node takes the word and its index. Each call to insert removes the first character of the word, uses it to find the right child to call, then recursively calls insert on that child with the rest of the word. If the word is empty, this means we have reached the end of the word. Since we want to know all words with a particular prefix, we add an index to the list of every node, not just the last one. The find function is similar. We keep recursing down the tree, removing the first character each time until the query is an empty string. We do have to make one modification though. In addition to stopping when the query is empty, we also stop when there's no word with a prefix that matches the next character. This allows us to return partial matches, which is what this question asks. Finally, in my try class, I added a dunder wrapper function, which handles pretty printing. This is Python's equivalent of a toString function in Java. Always good to have a toString for debugging. With the try, the problem becomes quite simple. The only trick is to reverse all strings in both words container and words query since we are looking for suffixes. Next, we insert all words from word container into the try. We call find for each query one by one. Find will return a list of indexes corresponding to words in words container. It's then straightforward to go through these words and pick out the shortest one. Now you know how to solve LeetCode problem 3093 longest common suffix query. Learn a new useful data structure in the try. Check the video description for where to download all the code we use today. If you enjoyed this video, please consider giving it a like and subscribing. This helps out small content creators like myself and lets you stay notified anytime there are new videos.